dear student, this is a Jib crane. These crane are used to lift a load. So here in the pan we are applying the load W. So when the load is applied on the Jib crane, the load gets distributed in the members of the Jib cranes. That is the Jib, this is the Jib, and this is a tie. So the W will get distributed here in the Jib and in the tie. So the vertical member is known as a post. So now we are considering this point will be remaining in the equilibrium conditions. So when the W are acting here, the member are subjected to the compression and the tie member are subjected to the tensions. So due to the compression and due to the tension, the length of the member will get changed. So here the length of the tie, length of the Jib will get decreased and length of the tie will get increased. So in the experimental, in the observation table, we have to measure the change in length during the experiments. So when the W are acting, suppose we are applying the 1000 gram load. After applying the load, we have to measure the length of the members. That is the final length of the member. And also we have to measure the length of this post from this point to these points. So every time we have to measure the length of the member, and then here when we are applying the load, we have to measure the how many forces are acting on the Jib and how many forces are acting on the tie. So for the purpose, the spring balance is given here. The spring balance can show how many forces are acting, that is a tensile forces, how many forces are acting in the tie member, and here also the spring balance is given. That spring balance can show how many forces are acting, that is a compressive force, how many compression force are acting on the Jib members. So in the observation table, the first column is given for serial numbers. So here we have to take the 5 readings. Then the second column is given for W, that is a load acting on the Jib cranes. So here we have to consider, when we are applying the load, we have to consider the weight of pan. So weight of pan is given, that is 150 gram, and we have to apply the initially we are starting from 1000 gram load. So for the first reading, the load is 1000 gram, and then we are increasing the load by 500 gram for each reading. So 1000 gram load plus the weight of pan. So for the first reading, the load will be 1150 gram load. So weight of pan we have to consider. Then the second column is given for length. So length is, so why we have to measure the length? Because we have to find out the forces are acting on the member theoretically also using the Lami's theorem. So there we have to plot the triangles of the forces. So for the purpose we have required the length of the members to plot the triangle of the forces. So the second column is given for length. So in the length, the first is the Jib length, then second will be the length of tie, and third will be the length of post. So that we have to measure. And when we are going to conduct the experiment, so we have to check there is a spring balance. So we have to check whether there is a initial reading in the spring balance or not. So whether any initial reading in the spring balance, that we have to note. So for the purpose, the next column is given, that is a initial reading. And then when we are applying the load in the pan, then we have to note how many will be the load acting in the jib with the help of the spring balance. Here the reading will be provided, and also we have to note how many load will be acting in the tie member. So for the purpose, spring balance will be provided. So that is our final reading. Then force experimentally, next column is given for force experimentally. So force experimentally is nothing but the final reading minus initial reading. So if initial reading is 0, then if the initial reading is 0, then the force experimentally will be the equal to the final reading. So that we have to know. And the next column is given for force theoretically. So force theoretically we have to find out with the help of means by applying the Lami's theorem there. Then we have to plot a triangle. Then we have to measure the angle between the forces, and then we have to apply the Lami's theorem, and then we have to find out the forces in the member of jib and forces in the member of tie. So that is the theoretical part that we will discuss in the next. But now for the experiment purpose, here we are applying the load, and then we are measuring the length, and then also we have to find. Then also we are noting how many forces here and how many forces are acting in the tie and how many forces are acting in the jib. So that is our experimental part. So now we will start our experiments by applying the load in the pan. Now for the first reading, the load will be 1000 gram. So now we are applying the 1000 gram load in the pan. So now the crane will be in the equilibrium condition. So we are measuring the length of the post, length of the jib, and then length of the tie. So steel rod is given here to measure the length of the jib, length of the tie, and length of the post. So the length of the post is 80 centimeter. Now we are measuring the length of the jib. Length of the jib is 125 centimeter. Then length of tie member, the length of the tie is 90 centimeters. So note down. Then force experimentally, force acting on the jib and force acting on the tie. On the both member, the initial reading is 0 and the final reading is, after applying the load, is 0.4 kg and 1.5 kg load are acting on the tie and 0.4 load are acting on the jib. Then the second reading, for the second reading, the load is 1500 gram plus the weight of pan, that is 150 gram. So the total load is 1650 gram. Now again we are measuring the length of the jib, length of the tie, and length of the post. So length of the post is constant, it will not get changed. Only the length of the tie and length of the jib will get changed. So that we have to only measure every time. So now length of the jib is 124.8 and length of the tie is 91. So here the length of the jib is getting increased, length of the jib is getting decreased, and length of the tie is getting increased due to the tensile force, and length of the jib is getting decreased due to the compressive force. Now the force acting on the jib is 1 kg,
2 kg.
and force acting on the tie is 2 kg. Then for the thrust reading, the load is 2000 gram plus 150 gram pan, so total load is 2150 gram. Now again we have to measure the length of the jib and length of the tie. So that we have to note how many length is decreases.
$124.6
124.6 for the last reading, 124.6 centimeter. For the last reading it is 124.8. And the length of the tie is 91.3. 91.3. Force acting on the jib is 1.8 kilogram. So 2.7 load are acting on the tie. Then for the next reading, the load is 2500 gram and weight of pan 150 gram. Now measure the length of the jib. Length of the jib is 123.4 centimeter and length of the tie is 91.4 centimeter. Force acting on the jib is 2.1 kg and load acting on the tie is 3.4 kg. Then the next reading, for the next reading the load is 3 kg plus 150 gram load of the pan. So total load is 3150 gram. Now again we are measuring the length of jib.
$120.5.
120.5. Now the length of tie. The length of tie is 92.5 centimeter. Force acting in the jib is 2.7 kg. 4.1. Force acting in the tie is 4.1 kg. to find out the forces theoretically, forces acting on the jib and forces acting on the tie. So for the purpose to find out the forces theoretically, we are using the Lami's theorems. So the Lami's theorem state that when the three forces are acting on a points are in equilibrium, then each forces is proportional to the sine and angle of the angle between the other forces. Consider the case, three forces are acting on a point, force A, B, C. The alpha is the angle between the force C and B, then beta is the angle between the force A and C, and gamma is the angle between the force A and B. So as per the Lami's theorem, when we are applying the Lami's theorem here, the equations we got after applying the Lami's theorem is A, the ratio of A divided by sine of opposite angle, that is sine of force A divided by sine of alpha is equal to B divided by sine of beta and C divided by sine of gamma. So now we are applying the Lami's theorem to find out the forces in the jib and tie. So firstly we will plotting the first triangles which can show the forces acting on the jib, forces acting on the tie and load W. So the vertical member is a post member, this inclined member is a jib, and this member is a tie. So this is the tie, this is the jib, this is the point R, and here the load W is acting in the downward directions. So when the W is acting here, the W's get distributed in the jib and the tie. So here this member jib is in compressions, so it will give the reactions to the compressions is in these directions. So this is the direction of reaction given by the jib, and tie is in tension, so it will give the reactions in the opposite direction to the tensile force. So this is the reaction given by the tie. So now this is the case. So when we are applying the Lami's theorem here, so this is the directions of the forces, that is the, we are considering this is the Fj, that is the force acting on the jib. So this is the direction of reaction given by the jib. So because reaction is equal to the forces acting on the members, whatever the forces are acting on the members, the reaction given by the member is equal to the forces acting on the members. So this is the direction of the force Fj, and then this is the direction of the force F, this is the direction of the force Ft. Here we are using the force acting, force given by the tie is Ft. So now here with this force diagram we have to show draw the space diagram. There where we have to find out the angle between the forces. So this is the point R. The downward force is a load W, and this force is a Fj, and this force is a Ft. So if you consider this is the angle alpha, this is the angle beta, and this is the angle gamma. So in this case, the Lami's theorem is given as W divided by sine of alpha is equal to Fj divided by, Fj is the force on the jib, divided by sine of beta, and is equal to Ft divided by sine of gamma. So in this way, we have to find out the forces on the jib and the forces on the tie. So here to find out the forces, one thing is important that is known to us, that is the angle between the forces alpha, beta and gamma. तो अल्फा बीटा गामा की वैल्यू अपने को नोन चाहिए, मालूम होना चाहिए फोर्सेस निकालने के लिए. लोड W तो अपने को मालूम है, because during the experimentations we are applying the load W, but we don't know the angle value of the angles, that is alpha, beta and gamma. So how to find out the value of the angles between the forces? तो उसके लिए अपने को निकालना है फोर्स ट्रायंगल और स्पेस डायग्राम. With the help of observation table, how to draw this diagram, that we will discuss. Okay. So now we have the length of the jib 125 centimeters, length of the tie is 90 centimeters and length of the post is 80 centimeters. This is from the reading number 1. So here firstly we have to take the suitable scale. So just consider this scale is 1 centimeter is equal to 20 centimeters. So we are considering this scale 1 centimeter is equal to 20 centimeters. So firstly we have to draw the vertical members. So vertical member is a post. The post की length है 80 centimeters. So as per the scale 1 centimeter is equal to 20 centimeters. So 80 centimeter का post कभी अपन notebook के ऊपर draw करेंगे तो that is not possible to draw the length of the post of 80 centimeters. So that's why we are considering the scale. उसके लिए अपन ने reduce करने के लिए उसको small में निकालने के लिए we are considering the scale. So here we are considering the scale 1 centimeter is equal to 20 centimeters. And now we are drawing the first vertical members. The first vertical member is a post. So this is a post member. So this length I am showing it is of 4 centimeter on the notebook. Actually में ये कितना length है 80 centimeter. But I have converted this 80 centimeter with respect to the scale. So 80 centimeter is converted into the 4 centimeter because 1 centimeter is equal to 20 centimeter. तो आपको एक vertical line draw करना है. That vertical line shows the post. This is the post. Then the second member you have to draw. The second member is jib. So length of the jib is given. So length of the jib is 125 centimeters. So convert that 125 centimeters into the scale. So 125 divided by 20 is given as 6.25. So now we have to draw the length. We have to draw the line of 6.25 centimeter. तो अपने को अभी line कितने सेंटीमीटर की निकालना है 6.25 because we have converted it with respect to the scale. Then similarly for tie की जो length है 90 centimeters. Again we are converting it with respect to the scale. So it is given as 4.5 centimeters. So here you have to draw the line of the jib is 6.25 centimeters and length of the tie is 4.5 centimeters after converting with respect to the scale. तो अभी क्या करना है कि then now you have to take the distance 6.25 centimeter distance this distance into the compass. Compass के अंदर आपको लेना है 6.25 distance and here you have to put जो steel point है steel point here you have to put the steel point on this. Suppose we considering this is the point A and this is the point B. So on the point B you have to put the steel point and the distance between the compass is 6.25 centimeters. 6.25 centimeters and then you have to mark the one arc at a distance of 6.25 centimeters. So this distance is a 6.25 centimeters. Then again you have to take the distance in between the compass is 4.5 centimeters. That is what to draw the tie. Tie निकालने के लिए आपको distance लेना है 4.5 centimeters. So now distance लेना है compass के अंदर 4.5 centimeters. Put the steel point here and again you can draw the arc. So at some distance it will get this two arc will get these two arc will get interacted at some point. So that point we will consider the point C. So now you can join this triangle by making the straight lines. So here this is the member tie and this is the member G. So now on the point C the load W is acting in the downward directions. Okay, so the reaction given by the G is in these directions, that is given as Fj. And reaction given by the tie is in this direction, that is given as Ft. So now on the point C के ऊपर भी तीन force act हो रहे हैं. So here you can show the C. Now this is our force triangle. Now this is the force triangle. Now we have to draw the space diagram where we have to find out the angle between the forces. तो क्या करना है कि इसके बाद with the help of these force triangles we have to draw the space diagram to show the angle between the forces. तो angle between the forces निकालने के लिए आप फिर से यहाँ पे पॉइंट शुरू करेंगे C C के ऊपर डाउनवर्ड डायरेक्शन में straightly in the downward direction the load is acting, that is W. So show here the line W which is in downward directions. This line and this line is in parallel. So these two lines should be parallel. ये लाइन और ये लाइन parallel होना चाहिए because load is acting in the downward sides. तो उसको कहा कि कौन से भी एंगल में निकालना नहीं है, उसको सीधा नीचे निकालना है, right? So next you have to show the jib. तो jib की डायरेक्शन है forces acting on the jib और reaction given by the jib is in these directions. तो यहाँ पे क्या करना है, पॉइंट C के ऊपर आपको एक लाइन निकालना है, that is showing the force Fj, and with the help of this diagram, with the help of this line, you have to draw the one line here which is parallel to this line. So this line and this line should be parallel. तो इसको पैरेलल लाइन आपको यहाँ पे निकालना है और that line will be starting from the point C and indicating the force Fj. Okay. Then similarly you have to draw the force Ft. ये लाइन तो पैरेलल लाइन, ये लाइन तो पैरेलल लाइन आपने को शो करना है यहाँ पे. Then here you are showing the line Ft. These two lines. These lines and these lines should be parallel. दोनों लाइन पैरेलल होना चाहिए. तो अभी ये लाइन पैरेलल है इसको. This line is parallel to this line and this line is parallel to this line. So likewise, you have to draw the space diagram. So now, what is the next work? Next work is to measure the angle between the forces. अभी आपको प्रोटेक्टर लेके इसके ऊपर पुट करना है और यहाँ से जीरो कंसीडर करके आपको एंगल बिटवीन द फोर्स मेजर करना है. ये एंगल आपको मेजर करना है, डायरेक्टली आपको मेजर करना है वहां पे उसके ऊपर प्रोटेक्टर रख के. सपोज दैट इज नॉट ए परफेक्ट वैल्यू, यू शुड बी मेजर इन. आप जो भी कैलकुलेशन करेंगे आप मेजर करेंगे और जो भी वैल्यू आएगा वो मुझे बताएंगे. लेकिन मैं आपको यहाँ पे जस्ट आई एम पुटिंग वन ऑफ द एग्जांपल विद यू. सपोज दिस इज एंगल 120. सपोज आई गॉट द एंगल 120, मुझे 120 मिला है एंड दिस इज 100. So now 120 plus 100 130 that is 230 और ये रहेगा मेरा नेक्स्ट एंगल इज सपोज दिस एंगल इज 130. So suppose I have got these three angles, angle between the force Fj and W is 120. ये मैंने मेजर करके एग्जांपल करके आपको पुट कर रहा हूँ. आपको मेजर करके आपको लिखना है वहाँ पे. That is just this is the example. This is not a perfect value, right? So here the angle between the force W and Fj is 120. Angle between the force Fj and Ft is 130, and angle between the Ft and W is 100. Right? So now you can apply the Lami's theorem here to find out the forces. So how the Lami's theorem is given as, this is the space diagram. So now the Lami's theorem is given as, so here we are applying the Lami's theorem. So by applying Lami's theorem, W divided by sine of 130, because we have to consider the opposite angle. So W के opposite, ये W है, उसके opposite angle है 130. So W divided by sine of 130 is equal to Fj divided by sine of 100 is equal to Ft divided by sine of 120. Sine of 120. So now for the reading number, अभी ये पूरा जो है पूरा reading number 1 के लिए है. So now for the reading number 1, the value of W is given as W is 1.15 kg divided by sine of 130 is equal to Fj divided by sine of 100. So Fj is given as, तो आपको यहाँ पर वैल्यू निकालना है Fj की, that is in terms of kg. Similarly, you have to use the second equations, this one and this one, first and third equations, to find out the value of Ft. तो Ft निकालने के लिए आपका इक्वेशन होगा 1.15 divided by sine of 130 is equal to ft divided by sine of 120. So ft is given as, that is 1.15 divided by sine 130 into sine of 120. तो यहाँ पे आपकी ft की वैल्यू निकल जाएगी. So in this way you have to find out the value of fj and ft. So this is our theoretical fj, that is forces in the jib, and ft is the forces in the tie. So in this way we will find out the value of forces in jib and tie theoretically. So now the next part is to find out the percentage error. So now we have the value of force experimentally and force theoretically. So with the help of these two values we have to find out the percentage error in between the jib value and the tie value. So the equations given for the percentage error in jib is force theoretically in jib minus force experimentally in jib divided by force theoretically in jib into 100. तो आपको जिब का फोर्स थ्योरेटिकल लेना है माइनस फोर्स एक्सपेरिमेंटली जिब, तो एक्सपेरिमेंटल वैल्यू ऑफ जिब की लेना है डिवाइड बाय फोर्स थ्योरेटिकली इन जिब इनटू 100. सिमिलरली फॉर परसेंटेज एरर इन टाई is given as force theoretical in tie minus force experimental in tie divided by force theoretical in tie into 100. So with these equations you have to find out the percentage error for the jib and the tie. Then the next part is the results. So results is the mean percentage error in jib member and mean percentage error in tie member. तो आपके पास परसेंटेज एरर के 5 वैल्यू है, जिप के लिए 5 वैल्यू है और टाई के लिए 5 वैल्यू है. तो वो पाँचों का आपको लेना है एवरेज, दैट इज मीन, एंड दैट मीन इज द रिजल्ट्स. तो वो 5 वैल्यू का मीन लेके दैट मीन परसेंटेज एरर इन जिप का मीन लेके आपको लिखना है जिप मेंबर के अंदर, एंड टाई का मीन लेके आपको लिखना है टाई मेंबर के अंदर. सो दैट इज अवर रिजल्ट्स. देन व्हाट यू लर्न फ्रॉम द एक्सपेरिमेंट्स दैट यू हैव टू राइट इन द कंक्लूजन्स. थैंक यू.